And we are good. So, first thing I want to express is the laser cutter is not a magical machine. It's really not. It's a very expensive one. It's about 30 grand. But really all it does is print, but instead of ink, it prints lasers, right? And very specific lasers. Whether that be a score, whether that be a cut, or a certain material, we can essentially tell this printer to print at certain cuts, right? So really all this does is accuracy and speed. That's really all we're adding to model making here, right? Don't get me wrong, we're also saving our wrists and maybe the cost of X-Acto blades as well. But I think a mistake that even I made as a student is I thought that, oh, it could just do everything, right? It could just cut everything, right? And that's definitely not the case. One thing I will refer to before we get started is exercise 5 is literally about this entire process. So if you want it broke down a little bit more, see exercise 5, part 1, part 2, part 3, and I'm making part 4 honestly tomorrow. But let me go ahead and get that file going.
So our goal, as he's pulling that up, is to show you this process of how you have to format your lines, and then go to the space, show you the machine, and actually cut some.
Correct.
Just to give you that taste, that and smell, because it definitely has a smell and texture to it. The whole experience does. And then I want to say, as he's also getting that ready, that bear in mind that just a year ago, a student in Design 4, about this time, a little bit later, ended up burning up the machine, right, melting it. And it took Brett 6 months to reconfigure that, to get another one to replace it. So you are capable of great significant cost and damage if you don't respect everything that's being told to you. In a way, right, the whole idea of each person doing a test sample is usually that you have to be supervised in order to be affirmed that you know how to use the machine respectfully. I don't know if that's going to be possible, right? Because Professor Barrett only has so many hours of the day and he has lots of responsibilities with his own classes and with his family. So we're asking you to assist each other. Like you only have one mentor, which is Kayla, that has used it, and you've used our machine, right? Kayla? Yeah, correct. So that is an important part for you to understand. Do not do anything that you are not assured of. Like really pay attention to the steps in the procedure. It is as critical to get a correct layout and formatting of your lines as it is to then understanding the settings of the machine and cutting it. All of that in this compressed space is a challenge, but we've done it successfully before. It's about one hand to one hand, maybe Kayla can assist 3 of you and then 3 of you can assist 3 more. It's that way of doing it, right? And all the time, I mean, not day or night, calling in Professor Barrett or any of that, or me, or whoever it is, right? But you're going to have to kind of respect the machine so that the machine respects you.
Absolutely.
Sense, right? Don't try to do anything you don't know how to do. Ask someone first.
Absolutely. Yeah, she had actually no right to use the machine. One of the, at least unspoken rules at the college, guys, is you need to take either this class or have some practice with the laser cutter and myself, or you take computer graphics with myself, and I do teach it every semester, and I'm really the only one who starts to teach it, right? I mean, even Professor Amin and Professor Tunks, they know about a laser cutter and they know how to set up a file. But when it comes to running the machine, usually at other schools, you're not even allowed to breathe on this machine, right? Because ours is worth 30 grand, theirs is worth like 150 grand. So I was actually a shop assistant at Texas Tech University, and yes, I got all free laser cuts, right? I got to laser cut all my models and get really, really good at laser cutting. However, one thing I would mention before we get started, I call it the puzzle method, right? So realistically, you want to kind of make a digital puzzle first, right? You want to get all the pieces set first. Don't think like, oh, I'll just get to it when I get to the laser cutter. No. The laser cutter is for a final product, right? That's really what it's for. And theoretically speaking, we're kind of using it to create a study model. And again, that's also just because we're experimenting with the capabilities of the machine, and obviously you're getting much more familiar with its capabilities and its limitations. But that being said, the first thing I would offer, guys, is for those of you who were organized in making this, hats off to you, because this part will be a lot simpler. You'll essentially go to your layers and essentially turn one off and on at a time. You'll build this piece by piece. But one thing I would express in that digital puzzle is when you have interlocking pieces, you may want to consider, what do we do with that, right? In this case, not an interlocking piece. I kind of want to find one that's interlocking. Oh, there's one, right? So we have these interlocking pieces, and you may need to ask yourself, hey, do I need to minus this one? Or do I need to subtract from this one? Any guesses? I'm probably going to subtract from this mass, right? Just because there's kind of a sliver there. And to be fair, the best way to do that is a Boolean difference or Boolean split. So I can type in Boolean. Split is probably my favorite because I can just put 2, enter. And of course, it's going to freak out on me. I'm going to have to use Boolean difference. Oh, there it goes. So now you see that its wireframe is now giving us a piece that is going to interlock with that piece. You guys see that? And it's going to leave us a piece that we actually don't even need.
That was a good sound.
Right? However, I accidentally subtracted from this one too. I may not want to necessarily do that. So I may want to add that piece back and simply just join it. If it can't join, that's okay. We can Boolean union something.
Raise your hand or
And we can
raise
put
your
that back
voice
together.
If you don't follow what he's saying, right? You know how to find that in yours.
However, I'm not going to do that for the sake of tutorial, but you'd want to do that to your entire digital model. Why? Because we can't break physics here. We can't have two objects be in the same literal space, right? That would break Newton's second law, that two objects can't be in the same place at a given time. So we need to do that for everything first. And I really mean every single bit and piece. That will honestly make it a little bit easier. Now, of course, I'm screen recording, so sometimes I freeze up if I click on something too fast. There we go. But I essentially want to do that for each piece. Now, once I was essentially finished with that, honestly, guys, I would make a copy of this. Why? Because nobody in the entire universe wants to do that again, right? And I don't have to. I don't have to mess up. I can make a copy, and if I do mess up, thank goodness I have a copy. Just take that piece and try again,
Please do that.
right? And gosh, I wish somebody told me that as a student. You have no idea, guys. I built the same model over and over again, and yeah, it got better, and I got better, but 18 hours I'll never get back, right? But in our case, for instance, let's say I was finished with that piece. I start to break it down. I start to turn off layers, right? And, well, not lock them, turn them off, right? And start to isolate some of that I did. And I'd want to make these one at a time. I'd make them layer by layer. In fact, I'd really even as an animation, right? I mean, don't get me wrong, I used to do that for days, like, what am I doing in my life, right? And I, get kind of sidetracked by, honestly, the greatness of the software. But in a reality,
For your analog pieces, right? You understand
absolutely.
What he just said, that's your analog. That's what you're going to be making that out of chipboard. You're going to be making that the whole thing. So it's one thing to make it yourself. Remember, we're not making. Some of you have more ambition than is possible. There is no way that we have the time, the money, or the ability for any of you to try to make your whole thing out of a laser cutter. This is just to sample it.
Absolutely.
See what's possible.
Right.
So all the things he's showing you now are also what you're going to be doing by hand.
Absolutely.
Okay? Yeah.
Question, James?
What is the minimum thickness that something can be that can be like laser cut it?
It's a pretty good question. You could cut as thin as a piece of paper.
Okay.
Yeah.
But y'all
I wouldn't
know
recommend it.
what
It's not
you
very
got for.
strong,
1/16
but-
is 1/32nd. Right.
But yeah, to continue, so let's just start off with one of the first fabrication methods is taking an object. Keep in mind it has to be a closed object. How do you know if it's closed? Well, if I type in what, enter, it'll tell me everything about this object. And I can do that essentially for any object, but you should see something that says valid polysurface. And yes, it's a closed solid polysurface. Keep in mind that's important if I want to unfold something. If it's not closed, I gotta search and find the hole or make a new object, to be completely honest with you. Because the unfolding isn't going to work for you. However, if you have a closed object, you can do unfold surface, because that's technically a polysurface, right, that we just read. I'll hit enter. I get a couple of options. I don't recommend exploding at first, right, because what exploding does is turn it into a bunch of single pieces. Let's see what that looks like real quick. So off in the distance, there it is. There's every piece of that unfolded. Now, don't get me wrong, that's great. And technically I could print those out. I could put it on a sheet and I can cut them by hand. No big deal. But that would be a long time. So let's not explode and let's try and see what it looks like not exploded. This is what I meant by sometimes I do it wrong on purpose. That way you kind of know what to do. Let's not explode it. And of course, let's keep the properties. Enter. And this model's kind of in the way, so let's try that again. It's at my 0, point, so. Keep in mind when you make 2D or unfold something, typically it tries to go to your origin. You guys probably know that already. So unroll surface. Oh, okay. That's a little bit formidable, right? But still not quite, right? I mean, obviously I can't have pieces that overlap on themselves. The laser cutter would actually make these intricate pieces that don't actually work with my piece. However, some of it does. For instance, this piece, that's pretty nice. I could laser cut that and essentially maybe even do other parts. Let's try it again. This time, let's try not keeping the properties.
And that is one of those elements that saves you so much time, right? Rather than measuring those one at a time, drawing those one at a time, creasing those one at a time, and folding, right? That's a good use of a machine.
Absolutely.
It just shows you.
And what's great about this is we can still explode it. So for instance, if I explode, I can find those pieces that I know will fit together and move them.
There you go.
I can know and see, oh, I got another one. So I'll take that one and move it too. I know I have two, so maybe I'll move that one as well. Now, these are all potentially something that I could definitely cut on a laser cutter. Now, the next step, and I know I'm kind of jumping to the end here, but as if I was going to set this up to actually be laser cut. Keep in mind that the laser cut only reads a top view, similar to AutoCAD or anything like that. Right now we're in a wireframe, so I'm going to switch to always a shaded. I don't expect anybody to work in wireframe. You'd have no idea what's shaded or not shaded in this case. Obviously, this is a mess. This ain't going to work here. And I'd almost ditch the object completely, you know, if this is what's going to start to happen. Don't get me wrong, I get something out of it though, right? And those are potentially something I could laser cut and fill in the rest analog, right? Not a big deal. Another way that I could tackle this is also called a contour method. So for instance, this object, if you will, if we take a look at it, it's extruded, right? It really has the same pieces kind of doing the exact same thing over and over again. So let's see what that actually looks like in a contour. And for instance, in this case, I would need to know what thickness of material. So I'm going to go with 1/8, right? I'm just going to assume it's 1/8 cardboard. I'm going to type in contour. I'm going to choose a direction for that contour. It says base point first. So I'm going to pick really that extrusion angle. So here's my base point. Here's my other side. It's going to ask for a distance. That distance of layer I want to be 0.125 inches. Enter. Suddenly I have a wireframe of this object. Well, that's really great because guess what I can do with a wireframe? I can cut it on a laser cutter. I can cut all those pieces out, glue them together, and nobody has to know, right? Well, it depends, right? I wouldn't maybe use corrugated cardboard because that's going to give me this kind of weird corrugated space, and maybe I want this to actually read as mass, right? So maybe I use chipboard because that's much more dense. Maybe I use basswood because I can sand it and I can make it even actually a homogeneous shape.
Or foam core and use it as your form board.
Exactly. Absolutely.
Everybody?
So hopefully that's making sense. Obviously I could take this piece, I can flatten it, rotate it a little bit, and get all those individual layers. Obviously, in my case, I usually go to the top view, take one layer at a time, and basically set up my sheet. Right, I got one layer, I got two layers, I got three layers.
This is the other critical thing to, because none of you can break the bank.
Now, obviously, I don't want to do this for the sake of tutorial, but I think you get the picture.
Don't cut one little piece out of a big chunk of something, please.
Absolutely. And you know what? We may actually even cut something like this today. I do want to do something that is easily folded. Don't get me wrong. I kind of picked a shape that would kind of not work on purpose, right? So that you would know what to do when it necessarily doesn't unfold. However, let's choose a shape that also does fold pretty well. I'm thinking of actually that shape that was in Annalise, that kind of box shape that was at the end. Obviously, some of these are very clear. You could probably unfold that just because there's not a lot interacting with it. And if you need a better shot, again, zoom extents is your best friend. Can't tell you how many times I probably click on that button the most. But yeah, in some cases you'll realize, well, this one has no intersections and it really just needs to line up with a piece. That's great. So maybe I'll take this one, and again, that's my copy. And I kind of do want to take from this one. That way I kind of bit by bit know which piece that I'm setting up, and I have everything in order still. Again, organization is key, and I really wish somebody told me that.
That's where you
Unroll
decide
surface.
consciously, where do we start?
Let's keep the
Where's
properties
something
this
that
time
everything else will
and
begin to
enter.
play off of?
Oh, would you look at that? That looks like it's going to be successful, doesn't it not? No overlapping, clear indication of fold. Don't worry, I've been doing this a long time. I can guess on some of these objects, right? But I'm not actually done here. I do need to still make this 2D. If we typed in what, it's actually still a surface. It's a poly surface, meaning multiple surfaces. In our case, I still need to make 2D. And I definitely want to maintain source layers, but again, I'd probably turn off tangent, hidden lines, anything that I'm about to laser cut, right? Because I don't need extra lines for it to do something that I don't necessarily want it to accidentally cut or accidentally score. So in my case, apply. Yes, it's going to make it around the origin. And voila, right? Of course, in French for there you are. There's a piece. However, you'll notice that some pieces are missing, no? So I may need to actually explode this first. Maybe I don't want this one. Let's explode that one first and try make 2D again. Now I'll leave them together. That way when I do make 2D, voila, there's the information. So again, be careful. Sometimes you need to explode something. Doesn't mean necessarily take it apart, but now they're separate pieces, right? And I may need that, right? Because now I simply change these to what? Oh, they're still together, right? So I need to explode it again. Now I have individual lines. Oh, I still don't have individual lines. What can I do? I've already done explode. Ungroup and explode. So ungroup, explode again. I need individual lines, and I'm going to keep trying until I do, and look at that. I've got it, right? However, this also means I have a bunch of doubles in here, probably. So actually there's a trick. Just make 2D again. If you actually have double lines, in this case, the wonderful student who burned up our $30,000 laser cutter, she had 6,000 lines in one spot.
Oh my God.
But the laser's going to do that. It's going to go, it doesn't know right from wrong. It just goes, hey, master told me 6,000 lines in one spot. So it did. Now, if she would have took my class and just made 2D, we could have saved a lot of money. So in our case, obviously I kind of want to get rid of this just because I accidentally made a double. But relatively speaking, I do have my initial lines now. I accidentally made a copy. So let's go ahead and move that. And honestly, let's cut these today, right? As you can see, I didn't get to go over the entire model, right? So as you can imagine, really the work here, guys, is deciphering and creating that digital puzzle. That's super important. You want to get this resolved in the digital world first before trying to, I mean, don't get me wrong, you can resolve it in the real world, you just cut it, right? I mean, you just get the X-Acto blade out and be like, I'll make you work, right? But if you want to save yourself some time and trouble, do that thinking where you can't mess up. You can make copies, you can do just about anything. But let's try two things today, because I do want to show you essentially how to cut these, and quite literally cut them and fold them today right in front of you. So I want to go as fast as possible. And the next thing that we need to do is create that piece of paper for the printer upstairs. Like I said, it's a printer. And this printer only prints one size of paper, at least a max, and that's 12 by 24.
Write that down, or
Now,
nothing you can do is gonna, obviously you can't possibly cut a 27-inch long piece, right?
exactly. And it's a good point. Because, well, I can cut anything smaller than 12 by 24, but I can't cut anything bigger. Now, what's really nice is this project is at 1-to-1 scale, so you don't have to do any scaling, you don't have to do anything like that. In my case, I'll type in 24 inches, enter, by 12 inches. And I just did that on a simple rectangle. And, oh, that's nice. Look at that. Fits all in one piece very nicely.
Typing in, right?
However,
Brain.
if it didn't, guys, it's not the end of the world either. I could still separate it right here. Right, I could take that piece, I could rotate it. Why not? Because I could simply put that back together in reality, right? I won't do that for today just because this piece actually does work, but you may run into a piece that's like, oh crap, it's just a hair too big, or you'll run into something like this. This happens to me all the time. I'm like, gosh dang it, right? And I have a huge laser cutter at home, so for that to happen to me is just ridiculous. So there's my piece, and let's get that other piece that we, you know, I'll get a couple of these to kind of show you, right? Let's get the ones that actually moved. And let's get these actually ready for the laser cutter. So don't get me wrong, I'm kind of working in a two-dimensional realm. I would want to confirm that I'm also two-dimensional as well. So I can go to my 3D view and go, oh, yep, that totally looks flat, right? Definitely flat. We can't we can't laser cut a three-dimensional object. It has to be a two-dimensional line. It has to be a curve. And to be fair, it has to be a very specific layer and line weight. So the next thing that I would do is freeze. No, I'm just kidding. New layer. I'm going to make a cut layer. And I'm going to make that blue.
Everybody taking notes. I hope you know what you're doing.
And hopefully I'm recording. I didn't check my mic. You know, you'd be surprised sometimes. It doesn't happen often now that I have a new computer. But, you know, sometimes I forget to hit the mic button. So don't blame me if you didn't take notes. So I basically just made it a cut and a score. Now the only thing that's important about these is that yes, they're continuous, but under print width, right? I want to double click there and I want to make sure it's hairline, because the accuracy of this laser cutter is, yes, a hairline. It can cut 0.0001 accuracy, which to be fair is not, I mean, Boeing uses 12 zeros, by the way, where we're using at least 3. So I do need to make that hairline, and I do need my score to also be hairline. You'll notice if it's not hairline for this layer, it won't cut. In fact, for the preview that I'm about to show you upstairs, it'll show nothing, and you'll be like, but there's lines there. Ah, but there's not hairlines there, so it doesn't read it, right? It reads it reads nothing. In our case, this happens to be the boundary of our object, right? The boundary of our paper, that 12 by 24. And if I wanted to verify, I could do dimension, D-I-M. And I could verify that dimension, 1 unit. If I wanted to actually make it inches, I could double click on this. Length units, feet and decimal, nah, feet and inches, right? So of course, I mean, it's an AutoCAD program. But again, verification is key when you're making something physical, when you're making something one-to-one. So be careful. You do want to verify these things, because if that's the wrong scale, everything inside of it is essentially either too big or too small, right? Some of you guys probably realized for this project that you just printed, you could have just drew a rectangle 36 inches by 24 inches and did all that wonderful work here. Would have been a lot easier than Illustrator, right? I see James shaking his head like, I hate Illustrator. Yeah, me too, right? Because I spent way too much time in doing so. But again, do it here, draw here, because it's accurate. I can dimension it, I can move it at a whim. So again, knowing that. Anyway, let's get this ready for the laser cutter. Naturally, what I normally do is just select everything and right click on cut and change object layer. Now immediately those should all turn blue. If they don't, make sure that you go to your properties and make sure that it's actually set by layer. So if you go to properties, you'll see it actually has the layer, and sometimes it says default, sometimes it says by parent, and you can switch that manually as well, but just make sure that it's actually on the right layer. Keep in mind, I do want to fold this. I don't necessarily want all these separate rectangles, right? I want them to stay together. So in my case, these all need to be scored.
It's really important.
Super important. Now keep in mind, some of these actually go in and out, but I'm gonna score it anyway to kind of show you the limitations of those folds. Don't get me wrong. Sometimes you fold it too much and it breaks. That's okay. Tape the other side. Nobody has to know, right? But in our case, let's go. Let's get it. Obviously, I don't want two separate pieces there. I want to fold there, fold, fold, and that looks like about all the folds. So I'll go back to my layers, right-click on Score, and change Object Layer. Naturally, they turn red. This is pretty much ready to go. Last but not least, we basically just need to export the file. And yes, we have Rhino 8 upstairs. It's taken 10 years to get Rhino 8 upstairs, but we finally have Rhino 8 upstairs. And this is essentially what you need to laser cut today. Now, I've actually already got a test piece for myself, and I know it's actually a slightly different dimension. So I may want to even add that dimension. So for instance, maybe I'm doing basswood that's exactly, I'm just gonna guess, 8 inches by 18 inches, right? Let's draw that. I mean, why fake it till we make it? We can't do that on a laser cut. I mean, you can, but it's dangerous, right? I don't recommend it. I'll draw a rectangle that's 8 by 18, so in my case 18 inches by 8 inches. That way I can discover if, well, what I'm about to cut today is even going to fit on that piece. Uh-oh, it's not. So I may need to move it around. I may need to adjust some things, right, to say the very least. Maybe put that off to the corner. Maybe I do need to separate these, or look at that, I can just turn it. Oh, you see what I mean? See what I mean? Like that little piece, right? The bane of my existence. So I may want to actually separate this. So what do? Oh man, I'll hit up Professor Verrett. No, right? I'll look at his tutorial, and I'll fill in the blanks. I'll draw a line because it's all two-dimensional, and I'll make sure that that line is a cut line. Change object layer. Awesome. You know, there's the previous line, so I'll change that to a cut too. Otherwise, it'll kind of be stuck on the board still, right? If I just score there, it's like it'll all get cut out. Now, don't get me wrong, I could just rip it out, but I don't want to do that to my piece. I want accuracy. So again, changing that to a cut. Now we're good. Now I have my piece. Now it's going to fit on that piece. It's going to fit on the laser cutter. We're good to go. Honestly, from here, we can save it. So in my case, that computer upstairs is pretty weak. Not gonna lie to you. It's not gonna open some of y'all's files that have a lot going on in it. So what I would recommend is just take the part that you're gonna cut. Open that in Rhino because you'll have a lot easier time on that computer upstairs. Unfortunately, and this should be changing soon, I'm trying to get a new computer there, but unfortunately the licensing file is stuck essentially in this computer, and getting a new one costs $5,000. So in order to avoid that, I'm working with IT to get this hard drive basically in a new computer, but that takes a lot of red tape and paperwork. So we'll make the best of it. And it does work, but you have to be gentle with it, right, as I would say. File, export selected, and we're just gonna save a Rhino 8 file. In my case, I'm gonna call it test laser cut today, or just Bohu. In my case, I do wanna make sure that I save it onto my flash drive and basically export that piece. Perfect. So now that we have that done, won't necessarily get this part on the recording, but I do want to emphasize that it is actually already recorded. So if you go over, great TED Talk by the way, showing that in my intro class yesterday. Pause, videos. Again, here's the exercise 5s, and here's the wonderful laser cut. I do update this every year because some things do change. For instance, we got a new laser cutter tube, and it is powerful. You do not have to add any more percentages if you're familiar with the past. So definitely watch this video, especially if you can't see today in the back, right? There's not a whole lot of room in that space. To be fair, some of these are quite detailed things that I'm pointing out, so keep in mind there is a video where the camera does get pretty close to clearly the same things that I'm saying. So just wanted to make sure you guys know where to find it. But we're good to go. Let's go upstairs and end this recording.